Hello, Prasad, and welcome to the Maintenance Analytics Summit, the first edition here in Stockholm. We're very pleased to have you with us. Before we go on into further questions, can you please tell us more about your background, your area of expertise?
Yeah, so I am coming from academic background. I work for University of Tromsø, but I think I am somewhat coming from a research and industrial background also. I used to work for several research institutes and then some industries also. And then I joined academic to contribute my work. So I was quite a lot of time working with the data, machine learning and AI. So that is how I kindly end up in this data analytics side of these industrial IoTs.
Okay, so Prasad, lately predictive maintenance is one of the most talked about topics when it comes to asset management and to maintenance. So where do you see the biggest challenges when it comes to deploying data into bringing value to the maintenance itself? And what is stopping companies to start with this approach, to consider this approach?
I think these new systems getting more and more intelligent, and these systems can collect data themselves. But often we don't have enough models to use this data. So even though we are collecting quite a lot of data, we don't know how to model. And then the other challenge is the quality of the data. The data set we have looked upon, we noticed there can be so many data quality issues. Sensors, when you have quite a lot of sensors in your systems, these sensors can fail often. And then you want to know how this is a sensor fault situation, also it is a good data quality situation. So I think this modeling side and then the quality of the data will be, I think, two of the challenges this industry is going to face in the present and the future. And these two issues will affect on your predictive side of the systems also. I think that is why some of the industries having big challenges. They don't know the accuracy of the prediction of their systems based on their data because of the same challenges that they have described.
Okay, so you gave a talk titled Reverse Engineering Approach for System Condition Monitoring under Big Data and Advanced Analytics. So what is the reverse engineering approach? How used it is? What industries?
Actually, we use this data for the shipping industry. We had quite a lot of data from ships, and often we haven't had approaches to analyze this data. So these are full-scale data sets coming out of ships. So what we thought about is when you're looking into the data, we thought about, okay, how do you start from the data and go towards the system? How do you reverse a system using the data? And we came across a simple, it may not be simple, but single framework which you can reverse these systems, and starting from the system level and you can go to a component level. And then these frameworks can be used for a condition monitoring and condition-based framework type of applications. So this is how we see solving this problem. So at the same time, we were addressing these data quality issues and data modeling issues using the same framework. So my presentation is about that type of a framework. How do you go backwards with this data to the component levels of your system?
Great. So during your presentation, at highly academic level, by the way, I think it matches with your professional background, academic one, you mentioned from industrial IoT to predictive analytics. So it sounds like a journey. Can you describe this?
Yeah, I think most of the time when we talk about this analytics, these are the analytics being developed by the data scientist may not be applicable for these industrial applications, because industrial IoT is something, I would say, somewhat different than the data being used by the other industries under data science. So we have quite a lot of additional challenges on top of analyzing the data. So that is why we were talking about starting from the industrial IoT and then go backwards with the predictive analytics. At the same time, we use some of the domain knowledge also during this analytic development process. So I think that may be one of the unique way we are approaching to solve this problem in relations to this predictive analytics.
And just a quick one, if I may. You mentioned the domain knowledge. How is it challenging nowadays? Is it applied enough? Are there people into it? Because how it sounds, it's like companies are struggling to get them.
Yeah, because often these data scientists are running this field. I would say they are the majority of people working, but they may not have that domain knowledge, or they may not integrate domain knowledge into their applications. So we think domain knowledge are really important, because of the industrial IoTs. You have to know what is a sensor fault versus what is a system abnormal event. So that can classify only through the domain knowledge, nothing else. So that's why we think the integration is really important during this development process.
Okay, great. So since this topic is somehow both new and old, if you get my intention, there are organizations who have still not started the journey. So for those, what, according to your expertise, what would your first suggestion be? How should they start? What should they prioritize?
I think, at least from our side, currently what we are doing in our research program is figuring out the quality of the data. And that could create a base for your work. So if you know the quality of your data, on top of that data, you can develop data analytics. So then those data analytics will be more accurate and your predictions will improve quite a lot. So we think that is how step by step wise you should develop these analytics. However, the data quality is important, and the domain knowledge is important, and combination of that. How do you know some of the data anomalies within your data sets, and identifying that, that's also really important. I think when you combine all these features, you might be able to do a really good job on developing this predictive analytics.
Okay, one last question, Prasad. What is your prediction about this topic in the future, in the near future?
I think we talk about quite a lot of AI and machine learning. Yes. In this field, of course, AI and machine learning will dominate quite a lot of areas. And what we were doing also related to this AI and machine learning algorithm. Future, I think there are good things, there are bad things. I think when AI dominate, there will be quite a lot of improvements in the field. But then some of the theories we have developed in this field might disappear also, because you are enhancing the information from the data. So those information is so powerful than some of the theories we have developed. So I would think that could be possible future in this field.
So predictive maintenance is no out from AI, as I can see, and that's really looking forward to it. It's really exciting.
Yeah, I mean, maintenance and some of the computer programming being used for a while, but AI, I think, create a new domain and new field and give new opportunities into this field.
Great, Prasad, it was a pleasure. Let me thank you for being here with us and for conducting this interview for our viewers. Thank you very much.
And thanks for the invitation also.
My pleasure.